Hello, my name is Goel and I'm from Utah. Today, upwards of 200 million gallons of wastewater are produced daily in the state of Utah. Utah is a relatively small state in the United States, population-wise, and when we consider the amount of total wastewater produced in the United States, the amount is staggering. Now, partially treated wastewater is many times dumped into water bodies such as rivers and lakes, and excessive nutrients present in the wastewater, primarily phosphorus and nitrogen, cause dangerous processes such as eutrophication and algae blooms. Now, these processes do two things usually. Firstly, they block out the sun and kill marine life, and second of all, humans swimming or fishing in the lakes and rivers can suffer dangerous illnesses. Now, the culprits of these processes, which are nitrogen and phosphorus, are actually the same nutrients used for high-yield fertilizers and high-yield seeds that are driving the agricultural revolution of this century, which is the reason we can continue to feed our ever-growing population, which is expected to reach 9.2 billion by 2050. Now, the problem comes because phosphorus is running out with an expected peak scarcity starting in 2030, with a top reaching 2050. So my project focused on recovering phosphorus from wastewater streams, 3 of which were tested, and those are gray water, leachate, and centrate. Now, we tested initial phosphorus levels to determine which one had the highest, and we conducted chemical precipitation on these wastewaters to recover the phosphorus. And our data shows that leachate had the highest phosphorus recovery with 89% at a pH of 10 when we did our chemical processes. This shows that wastewater precipitation is a viable strategy for recovering phosphorus, and with ever-growing populations, this process can solve 2 problems. It can limit water pollution because of phosphorus and nitrogen, and it can also guarantee a way for phosphorus, and we can continue to make fertilizers and high-yield seeds for generations to come.